All right, well, this is session number 22 of the Podcast Engineering Show. Here's the band. Yeah. Wow. Right, I always talk over that part. I come in earlier. I wanted to let the music play a little bit in this episode. Welcome, everyone, to the show, the Podcast Engineering Show, and I'm actually going to go through the outline of my introduction this time, because I gotten in the habit of winging it, and then I forget things. So my name's Chris Curran. I produce podcasts for Forbes, Dun & Bradstreet, and select business authors and companies. Each week on this show, we bring you podcast production techniques on a silver platter. We get down and dirty. We really talk shop with podcast producers, engineers, and other specialists, experts. And I'm psyched for who we have today on the show. This is going to blow your mind. We're going to get into the weeds. We're going to get into all the details of Auphonic. I have a background in audio engineering, and when I entered the world of podcasting about 4 years ago, I realized that most podcasters and podcast producers do not have a lot of audio engineering skills. The fundamentals are kind of lacking. So that's what this show's all about. I bring my background, and we talk about the audio engineering side of podcasting, and that way you can learn and have everything in your world sound better, whether you're doing your own podcast or whether you're producing shows for other people. Of course, Barry's with me here. Barry, are you ready for this episode today?
Yeah. Oh, yeah.
Okay. What are we going to need to get a good interview here today?
You're going to need a couple of horses or a couple of mules.
Right? We never have that, Barry. It's unbelievable. The website, Podcast Engineering School. That's right. Podcast Engineering School. Courses and workshops to help you get your audio skills up. In fact, by the time this airs, will already be done. But I'm doing a little 3-hour workshop on EQ and compression here in Colorado Springs. It's an in-person workshop. We're going to work in the box and with actual hardware, EQs and compressors, twisting knobs. It's going to be so cool. So podcastengineeringschool.com is where you can find details about the school, and the podcast is hosted on that site as well. So, and of course, you can listen to the show anywhere you hear a podcast: iTunes, Stitcher, TuneIn Radio, Google Play, all that stuff. So without further delay, let me introduce Georg Holzmann. He's the founder of Auphonic, and everyone knows Auphonic. Everyone uses Auphonic. So, Georg, welcome to the show.
Hello, Chris. Thanks for inviting me.
Yeah, happy you can be here. I mean, there's a major podcast network that I recently contacted and asked to be in touch with one of their engineers, so one of their engineers could possibly be on this show. And this podcast network got back to me and said, "Well, we just put everything through Auphonic, so I don't know if there's anyone here to speak to about anything deeper than that." So you have really created something that especially the world of podcasting knows and loves. So we're going to get into some of the technical aspects of it, but so if people don't know what Auphonic is, why don't you just give the little 60-second pitch of what is Auphonic and when did you start? How long have you guys been around, actually?
Oh, well, so I think the first version of our system came online in May 2012, but we were working, of course, a few years before already on it. So, well, yes, in 60 seconds. Well, what is Auphonic? I mean, it started as a web service, basically, so where you can upload an audio file, like a podcast recording, and we try to automate all the post-processing work. So this means evening out the levels and taking out some noise or mixing and everything. And also the part of encoding into multiple audio file formats and adding metadata or processing videos, and also then to distribute it automatically to different services like to YouTube or SoundCloud, Libsyn. So basically that you just have your audio file and all the rest is done automatically, and you can store it in a preset and then start the workflow with one or a few more clicks.
Right. Yeah, that's actually, I know Auphonic does a lot. It does everything you just said. I actually only use it for the audio processing part of it. Like I don't use it to tag MP3s or really upload it anywhere. I don't do that yet. I don't know if I would or will. But I just use it for the audio processing because, in podcasting, look, let's be honest. What happens is podcasters have cheap equipment, cheap microphones, and a lot of times they don't know how to work the equipment well, and they don't know a lot of times how to speak into a microphone. So the audio that's recorded is very shady. It's what's the word? Irregular. There's highs and lows, and it's loud and soft, and there's noise and there's reverb. And in fact, I was talking to a fellow podcast engineer yesterday. His name is Charles Gamel. He's going to be on the show as well. And he said, with his clients, he almost doesn't consider it engineering. He almost considers it audio restoration because some of this audio is really difficult to make it sound good. And Auphonic is like the shortcut. It's like the ultimate shortcut. So, and I like the fact that you guys on your website give this description. We develop next generation audio algorithms using a combination of music information retrieval, machine learning, signal processing, and big data to create automatic audio post-production software. So automatic post-production software, I like that. Now, when it comes to just audio processing, is there any machine learning involved, or is it just the signal processing stuff?
Well, it is always both. So the thing is, if you get a file and you're not a human, you somehow have to decide where is what. So basically, we analyze the file first. So you will see, or the computer will see, okay, here are music parts, and here are different speakers, or here's just a pause, or nothing is happening, or there are different kinds of background noise scenarios. So you have to know what's inside the file, and only if you know that, you can apply the different signal processing algorithms like compressors or filters and limiters and all this. So the machine learning part tries to understand what's inside in the audio, so that we can automate the parameters of the signal processing algorithms.
So how does the machine actually tell, how does the machine distinguish between two voices? Because this is a classic in podcasting. There's an interview happening, person A and person B. Person A is really loud, person B is really low, and when you put it through Auphonic, it levels it out. It brings person B up to the level of person A. So how does the machine actually know which voice is which?
Well, the machine learns it from examples. So we have lots of data on our servers, which are learning from the data which is coming in, and the algorithms try to classify the different speakers. So they try to segment, to calculate different segments from a file where there are different speakers.
Okay.
It's called segmentation, speaker prioritization or segmentation.
Okay. So does each voice have its own specific characteristic, like a fingerprint? Is the machine able to scan for that kind of thing?
Well, the machine does not identify the voice, so I don't know who is speaking. So we are not the CIA or NSA. we just know, okay, here is a voice and here is a different voice, but we don't know which voice or which human is behind this voice. So it's just about to get the boundaries where are different speakers.
I see. So it sort of analyzes each section. So person A in the beginning of the interview, let's say in the middle of the interview, Auphonic is scanning that voice. It doesn't know that it's the same person A from the beginning of the interview. It just knows it's a voice in a segment.
Well, yes, it might know that it's the same voice. So, for example, if we have our interview now and you process it, the algorithms will most of the time understand that there are two different voices. Oh. So they know that my voice sounds somehow different than your voice. And so they will segment the audio file into these two voices. So I know I am speaking now and you are speaking afterwards, but they don't know that I am Georg Holzmann and you are Chris Curran, so it's just segmented.
Not yet. That's coming, Georg.
Yeah, maybe in the next version.
No, probably the NSA already has that, I would think.
Yeah, sure.
Right?
Of course.
Yeah. Well, the aliens probably brought it down, right? All right, now we're getting off track. So it knows the different voices. So that's the machine learning. What else does the machine actually learn?
Well, there are a lot of technical parameters which are decided by the machine learning algorithm. So, for example, one big thing is also, of course, music. So if there are music parts, the music parts must be processed totally different. For example, two different speakers. If there are big level differences between the speakers, they are evened out nearly completely. So a loud voice is sounding quite similar to a quiet voice afterwards. But in music parts is of course totally different because music has a lot of inner dynamics. So there are quiet parts and loud parts, and they should not be compressed totally.
Right.
Because otherwise everything would just sound the same.
Yeah.
Which is not good. Or for example, especially in audio restoration, there are a lot of classifier decisions. So another thing is, if you have some background noise, the background noise could change during a recording. For example, we record here now in a room, then we make a recording in another room or outside. So, and then the background noise will change at this point. So we have to detect where these points are and take different noise samples from the different segments. So there are various small technical decisions which are driven by these algorithms.
Oh, that is pretty cool. That it can. I did not know that it can take noise samples from different parts, and that I love that. Now, as far as processing the actual audio, like again, let's use our two voices example. You're leveling it. That's one thing, but you're also processing it in terms of compression or limiting, right? So, do you always use compression and limiting, or do you use some compression, some limiting, or how does that work?
So we have a few algorithms which you can enable or disable. So if you enable it's called adaptive leveler. So if the leveler is enabled, then compression will be applied too. Oh. It's not always the same. It depends how the input material is. So if it's already quite compressed, there won't be added much compression anymore. But if it's not compressed, then we will add some gentle compression.
How do you scan and determine how much a voice is compressed that you're receiving? Like from the start, how do you determine how much a voice is compressed?
Well, you see it in the statistics, how much changes in the dynamics. So if it is already a lot compressed, then you will see that the dynamic is decreased and the peaks are not so far away from the loudness anymore. So you can somehow measure how much it's compressed already. I
see. So you're measuring the dynamic range pretty much.
Yeah, exactly. Okay. Dynamic range, yeah.
And it's an average, right?
Well, it's an running average, so it's always updated according to the current content. Oh, it's not an average over the whole file. It's an average over a segment, for example, or over a smaller part of a file.
I see. That's one of the things I have been experiencing in processing audio. The amount of compression on a voice, it affects the mix a lot. Like if one voice is not compressed at all and the other one is compressed a lot, it's sort of difficult to level them, perceptually to the ear, because it's just strange. So you kind of you almost have to, if you're doing it by hand, you have to match the compression at least somewhat between two voices, so they have a similar amount of compression on them, and then it's easier to balance them with each other.
Yeah, best is of course if it's not compressed at all before, then we can just do everything from a neutral source material, and then it's the easiest and best way.
Right? Yeah. Well, it's always good to do everything the best way and from the start, because then you don't have to fix it. I'm just curious, this this big data part of your company, do you actually keep all the statistics of audio and sort of refer to them? Or like, are you keeping statistics and data on all the audio you process to use that to process it better in the future?
Yes, we don't store the audio data. So the audio data is deleted after 21 days because otherwise we would need really big storage machines. But our machine learning algorithms are trained by the audio data, and we just keep the models. So we can't go back from the models to the audio which went in, but it's just somehow the algorithms are updated all the time by the data we get in, so that the model are updated.
And now when you upload audio to Auphonic, which by the way, you do have desktop apps and I use the multi-track Auphonic sometimes, which I have on my machine. I guess there's a cost to that, but I was like, this is pretty cool. So I bought it and it's on my desktop. But when Auphonic processes a piece of audio, it first scans it and does all these tests and scanning and determining levels and dynamic range and all that. And of course, noise reduction as well. And then it applies the processing to it. Does it just do that once, or does it process the audio and then sort of scan it again and determine, hey, is this good enough? Did it work? Did the processing actually work? Is it a one-step processing process, or do you sometimes go back and adjust?
No, it's a multi-step process. So it depends, of course, on the algorithms, but most of the time you do something, then you analyze if you need more or if it's enough, and then you go back and it's going on and forth. Of course, not everywhere, but on many steps, it is going multiple steps. You have to limit it at one point because otherwise it could process forever. But in theory, it's a multi-step process.
Okay. So I just want to mention to you listening that after you process audio on Auphonic on the website, just one file at a time, and it says, okay, it's done. Here's your download link. And it gives you a little picture of the wave, actually. And then underneath that, it shows you audio processing statistics. And this is the kind of thing we're talking about, the dynamic range, the loudness range. We're going to actually go through this list because there's a bunch of cool stuff on here. But first, I want to ask you about a couple practical things that I've experienced with Auphonic. Sometimes, like we just talked about, matching the levels of compression is helpful when you're trying to balance two voices. One thing that has happened to me in Auphonic is I'll put two voices in there, and the equalization of each voice will be a little different. And it always seems like the voice that has like more low end, more bass, because we know that bass carries more level, right? I don't know how to say that.
Yeah.
The more bassy a signal is, when you add bass, you're adding a lot of dB, basically. So when a voice is more mid-rangey, it seems to end up louder in Auphonic because Auphonic, I guess, is just saying, look, we're going to average this voice to minus 18 LUFS, let's say. And we're gonna average the more bassy voice to minus 18, but the bassy voice, because it has more bass in it, the bass takes up more of the loudness, so it doesn't seem as loud. Have you experienced that?
Well, that's of course a different problem because the loudness perception of every human is totally different. Well, we are using the loudness model of which also all the broadcast loudness standards are using. So basically, you don't, as you were saying before, the low frequencies are not perceived by the human ear as loud as the mid frequencies, for example. So the human ear has its peak at 1,000 to 4,000 hertz, and if you have lots of low frequency content, then this doesn't matter for the ear very much, especially not for speech intelligibility. But because of this human perception of loudness, we of course use a loudness model which filters away the low frequencies, so they are so that they are not taking into the measure of the loudness. And so basically, it's the low frequencies are filtered and the high frequencies are a bit raised. So this is similar to the perception of most humans. But of course, as everyone is different, everyone hears a little bit different, and also the model is of course not 100% perfect. But that's the current reference model which everyone is using.
Right. Okay, that makes sense. And now that I was thinking about it, I think I've experienced it opposite as well, where a voice with more bass, it actually seems louder. Because
yes,
if you're just processing the mid range, if you're lining up the mid range to be the same loudness with each other, if one voice has a lot more bass, that'll seem louder. Anyway, it's interesting.
Well, it's not that we just measuring the mid range, but
okay.
Basically, do you know this curve of human perception of? It's called equal loudness contours.
Yes, the Fletcher-Munson curve. We talked about it last episode.
They are basically curves how the human ear is perceiving loudness, and of course, this is different for every human, for every age, for every gender, and whatever. And this is just an approximation of the standard human, so to say.
Got it.
And if you're a little bit different, then it's of course different for you, and it's different for me. But somehow we have to approximate it.
Right. All right. So this brings up filtering. There is a button in Auphonic where you can say also use the filtering. Now, and I read that it's the low end filtering. So do you when you do filtering in Auphonic, it's not just across the whole track. Is it intelligent? Does it notice when there's parts with a lot of low end and just filter those out and leave the rest alone?
Yes, this filtering box is just cutting out the low ends, and so that you don't have all this wind noise and bumping and so on in your file. And this makes it in the same way, so it analyzes the file. For example, if there is a male speaker, you can remove everything maybe below 60, 70 hertz, or if there is a female speaker, you can go up with this limit. But if there is music, for example, and there is a bass playing in the music, then you also need these low frequencies. And so you have to analyze the file first so that you know where can I put my filter to cut all the rest and to avoid all the disturbing sounds in the low end.
Right. Yeah, the low end, this is one of the things I've noticed about podcasting in general. There's a lot of low end in microphone signals and in other signals, and it, to come across to the listener as to sound good, you got to get rid of a lot of low end. Sometimes, obviously, you have to use your ear, but that's one thing that I think a lot of podcasters don't ever do is filter out the low end. Like I've said on previous shows, I think every time I EQ a voice, I start with the low end filter, and I play with it. I'll put it up to 100, I'll put it down to 40, I'll put it up to 300, and cut out so it sounds like a telephone, and I'll find out where it sounds good, and that's how you do it, right? That's how you find out what sounds good, because you play with it. Another button you have, especially in the multi-track Auphonic, you have this button that does cross-gating. So if you're taking the example that we're using with two people, if they're in the same room, you can click this little cross-gating box, and that lets Auphonic know that they're in the same room and that it can sort of gate out, like it can remove someone if they're not speaking, it can lower their microphone. Is that how it works?
Yes, exactly. So maybe I should explain a little bit our two different versions.
Please.
So we have this standard version, or the version which most people use at the first time, which is the so-called single track version. So you have one file where you have all your recording, and you have everything mixed up already, and you just send this one file to our service or use our desktop version, and then this one file is processed. This is, of course, much more difficult in terms of processing because the different speakers or music is already mixed up. So we cannot really process the individual tracks of the individual speakers anymore. And there is a second version, which is the multi-track version, where you don't upload one file or you don't give one file as input, but you give multiple files as input, so one file for each track. So for example, in our interview, you could give one file for me and one file for you, maybe another file for your music and intro and outro music. And then we have the individual sources. And now it's, of course, much easier to do the processing, and it can be done much better because we can, for example, do the noise reduction in the individual tracks or do the gating, do more advanced gating, because we exactly know when you are speaking or when I am speaking. So it's much easier to distinguish the tracks. And as you were asking now for the Crossgate, the Crossgate is a feature, as you already told, if you make an interview in one room, and I have a microphone, you have a microphone, and then, of course, the signal from my voice is not only captured by my microphone, but also by your microphone. It's, of course, more quiet, but it's also there. And vice versa as well. And therefore, you get an echo-like effect if you mix down these two tracks. And our Crossgate removes this cross signal from my voice to your microphone and from your voice to my microphone.
Right, and that's really helpful. Which, of course, it's interesting. You can do everything Auphonic does by hand by yourself, but it just takes some equipment, a lot of plugins, and yeah. So that's why people use Auphonic, because it's all done for you.
You can do everything yourself. Of course. It's just a matter of time and cost.
Yeah, you can build your own car if you want. Go ahead, right? Create your own automobile, build your own house. Yeah, right. All right, so now let's go through the statistics and stuff, because, by the way, loudness is one of the main reasons a lot of people use Auphonic, the loudness standards, and, setting the level of a track or a podcast episode or a voice at a certain LUFS level, which LUFS is the new loudness standard, and there's different LUFS levels for different types of, broadcasting and podcasting and all this. So loudness is a big deal. Did you build in the LUFS from the very beginning of Auphonic back in May 2012?
Yes, of course. Actually, it was even more funnier because when all this loudness stuff started, we started the Auphonic project already before, or at least when I started the project, I did not know about all this loudness work, which was done by the EBU, the European Broadcasting Union. So basically, I were building something similar myself in the first 2 years, and then I started to notice that the EBU is building something similar and switched to their system, which was basically quite similar. So it was not much different. It was just another number. And so yes, I think when we started in May 2012, the loudness normalization was already built in, because it's very useful, especially if all TV stations are using it now, and if radio stations are more and more switching to it, also the internet streaming platforms, also YouTube and so on. So it's really a very great measure to somehow synchronize the loudness of different sources, because previously it was just totally mixed up. So you could never know how loud is this, or how loud should you mix your recording or your podcast. It was really crazy if you see it from today.
Right. Okay, good. So let's go through these audio processing statistics. I think this is very interesting because, like I said before, when you process an audio, a piece of audio with Auphonic, when it's done, it gives you the download link, of course, and then it gives you these audio processing statistics. And what's cool is it gives you the stats for the input file, and then right next to it gives you the stats of the output file. So, for instance, the first one is program loudness. And the output file, by the way, I'm looking at an example here. I will take a screenshot of this and put it in the post on podcastengineeringschool.com, so you can actually see the screenshot of what I'm looking at and discussing right now. So if you're listening, you can go there now and look at it as I'm talking. podcastengineeringschool.com. So the first item on the list is program loudness. The output file, it says, is minus 18.00 LUFS. So it's minus 18 LUFS, which is what I told Auphonic to set the output as, which is cool. I set it at minus 18 because because I take this file and then I don't do my final mix yet. But I think the loudness standard for podcasting in general is minus 16 LUFS. Is that right, Georg?
Yes, it's the general recommendation, but there is no real standard, no official standard. But minus 16 is what most people use and what also we have as a default setting. So if you produce a podcast, that's a good value to go.
Right? Okay. So it's for the program loudness. The output, it says minus 18 LUFS. The input says minus 22.23 LUFS. So that's when you basically scan the original file and figure out what the LUFS is, and that's what that number is.
Yeah, maybe just a little bit explanation of the program loudness. So the program loudness is just the average loudness of the whole file. So it's all individual parts are measured and added up, and then you calculate a big mean value of all these segments and get one number. And this is the number, so the lower, the quieter, the higher, the louder.
Right. Okay, the next item on the list is max peak level. And on the input file, it's actually blank. And on the output file, it says minus 1 dBTP. So what is that minus 1 dBTP for the max peak level?
This is called true peak level. So the peak level is actually the highest value. If you see the waveform in an audio editor, you have always these lines, and the highest point of these lines is the peak level, and the maximum of it, so the highest of the highest,
right,
is the maximum peak level. And usually, before all these loudness standards, the peak level was used as the main measure on how to normalize a file. So I guess all of you remember this normalize function in all audio editors. They basically just normalized the audio according to this peak level. But the problem is that the peak level does not say much about the loudness of a file. And so here this peak level means that it's at minus 1 dB, and it is a true peak level, which means that if you have digital samples, so for example, a CD has a sampling rate of 44,100 samples per second. So you have all these individual samples, and the maximum peak would be just the highest value of these samples, of these 44,100 samples. But the problem is, if you convert this digital file to an analog signal again, like for example, you play it on a loudspeaker in your computer, or you hear it with a headphone, then these individual samples are converted to analog, and they will produce a continuous signal. So there are much more samples in the analog world. And the problem now is that the highest peak can be higher than the highest peak of the samples. So therefore we oversample the signal. So usually this takes 4 times oversampling. So if we are at the previous example, so we have 44,100 samples, then we oversample it 4 times, which means we have 120,000 something samples. And now we take the maximum value of these 120,000 samples. And this is more exact than just the 100,000 samples. It's a bit complicated.
So let me see if I got it straight. So to determine the true peak level of minus 1, you actually convert the file, oversample it to many more samples and scan all them, and then is that how you get the true peak level?
Exactly.
Okay.
Actually, this is built into the limiter. So the last element of the Auphonic processing is a true peak limiter, and you can set the maximum true peak level. And in the web version, the default setting is minus 1. That's why you're seeing minus 1 here. But for example, in the desktop application, you can also set different true peak levels. So it's user definable.
Got it. And I've heard different people say different things about how close to 0 you should get. The default on the web version is -1 true peak. I've heard minus 0.2 is okay. It's okay to go up that loud. What's the danger in going closer to 0, Georg?
Yes, the problem is, one problem is what I just tried to explain before, because in the analog, if you convert a signal to the analog world again, the peaks will be higher.
Got it.
That's why we do oversampling. And in theory, we would have to do unlimited oversampling to get the real analog value. Huh. But the other thing is, of course, that most of the time you don't use the uncompressed format to distribute your podcast, but you convert the file to MP3 or to AAC afterwards, and then distribute this compressed MP3 or AAC file to your podcast listeners. And all these encoders, all these MP3 encoders, for example, they are very, they can react on this peak values. So for example, if you have a peak level of -1 now, and then encode it to MP3, the peak level might be +4, because they will introduce higher peaks.
Oh.
And you can never guarantee that the peaks won't be above 0. But a common practice is to set it at -1, or in other standards it's -2. But yeah, you can always have overshoots. You can always have some short clippings. But the lower you get with the peak value, the less probable are the overshoots afterwards.
I see. All right, next item on the list. Again, we're going through the audio processing statistics here after a piece of audio has been processed. The third one on the list is loudness range, and this one seems really interesting. And I also want to know, is there a standard for the loudness range? Because this is part of the whole LUFS thing, I think. So the input file, just using our example, is 5.67 LU, and the output file is 2.15 LU. So the output file, the range is less, which makes sense because it's either compressed or limited, which is what we want. But what is the loudness range, and is there a standard?
Yes, the loudness range is also defined in this R128 standard, which is the main loudness standard which is used by the television companies or stations. And what is the loudness range? So the loudness range is a measure of the dynamic range, as you told before already. So of the difference of the levels. So if there are lots of parts with higher levels and lower levels, then the loudness range will be big. If the levels are all basically the same, then the loudness range will be smaller. There is no standard on how to set this value, and this would also be very dangerous, because this is not really a measure where you could say you have to use a loudness range of 3 or 4, because it's very different for all different kinds of material.
Right.
But it's a good indication if you have, for example, a very high value, then you know that you must apply some compression, for example, or that you have to compress it in some other ways, because otherwise it would sound problematic on a speaker system in a living room if there are very loud parts and very low parts. But for example, in the cinema, it might be perfectly well, because you really need this dynamic and loud and soft parts. But yeah, you should not use this value with a strict rule on how this value should be. It's more just a description of the content, and yeah,
right.
You should be careful.
Right. It's interesting. So maybe if it is an interview between two voices, like I think the loudness range, I'm doing air quotes, the suggested loudness range should be different for each type of thing. So for instance, a podcast where there's two human voices talking, you probably could set a suggested loudness range there, because it's just two voices and it's meant to be heard as a podcast or a radio show. So you don't want the volume to get too low, because people need to hear it. But like you said, different types of material, music, even whispering or quiet, or like an explosion or something that's supposed to be loud. Like obviously that's the whole thing with dynamic range is that that's how we hear as human beings. Some things are really soft, some things are loud, and sometimes you want that, right?
Yeah, sure. But even for an interview with two people, it would be difficult because maybe you need a longer pause in your interview where you play some quiet music, and maybe that's intended. So
right.
This would totally change your loudness range value.
Right. Okay, so the next thing's on the list. It says max momentary loudness and max short-term loudness. So are these really important, or is this kind of just a statistic? And maybe you could tell us what they are really quick.
Yes. These are, of course, just statistics, but they can be important as well. So what does it mean? I have to look about the exact numbers. I think it's, the momentary loudness is a value. It is, we were speaking about the program loudness before. The program loudness is the mean loudness value in the whole file.
Right.
And the momentary loudness is the loudness not in the whole file, but from the 3 seconds. So it's only from the point where we are now and 3 seconds about this point.
Right.
I think it's 3 seconds. I might be wrong, but I think it's 3 seconds. And the short-term loudness is the same, but from 400 milliseconds.
Oh.
So the short-term loudness is a very short measure. You get lots of values from these. The momentary loudness is a bit longer. And there are some regulations, for example, on commercials, that they should not exceed a specific short-term loudness value or momentary loudness value. Because you could have one very loud sound, for example, an explosion, and then this would produce a high short-term loudness value. And some commercial regulate also this short-term loudness value or momentary loudness values. So this might be important for you if you produce for specific producers or for specific companies or institutions.
Right. Yeah, because that's the one thing about loudness that, I don't know, maybe you can tell me if this has been figured out yet, but let's say I make a 1-hour podcast where I'm literally whispering the whole time very quietly. And then for 3 seconds in the middle, I play a nuclear explosion that is as loud as can be loud. How, if you take the LUFS level of that whole file, it's weird. Like, how do you so that's where this stuff comes in, the momentary loudness and the short term. I kind of like that. That's how you would be able to tell that, oh my God, for 3 seconds in the middle, this went up to 0 or something, right?
Yeah, sure. Because it comes from DV, because before all these loudness standards, at least here in Europe, I don't know how it was in the US, you always had the DV program, and then there were commercials, and the commercials were much louder than the usual DV program. And one reason why they created these loudness standards was that the commercials have to be at the same loudness than the film, for example, which is going on before. But then the commercial producers, of course, had the idea, like you said before, to make a very soft commercial. And at one point, they speak very loud to get their message over the air. And then they are very soft again. And so they somehow cheated, of course. And that's why they introduced this new measure or it's not a new measure, but they introduced this additional measure of momentary and short-term loudness so that these things cannot happen.
Right. Okay. So let's move down the list. The next 3 are leveler gain. They're all leveler gain. The first one is leveler gain mean, leveler gain minimum, and leveler gain maximum. I guess that's just how much you're actually, at different points, how much you're boosting the signal, right?
Exactly. How much our leveling algorithm is changing your input file.
Now, when you change the level, is it like a fader where it's continuous, like it raises something and lowers it gradually, or do you just literally take a segment of audio, like a block of audio, and just boost it like 4 dB if that's what it needs?
Yes, this is different. So it depends on the context. For example, sometimes it's better to make very fast fades. For example, if we are two speakers and I'm much more quiet than you, if we always fade for a second, then you will always hear the fade, and it would not sound quite good. So we have to make the fade very fast. The best would be to make the fade between the pause when you stop speaking and I start speaking. So in this short segment of time, we must adjust the level so that afterwards it sounds the same or similar.
I see.
Otherwise, in music parts, it's of course often better to make slower fades, because then you don't recognize that the volume is changed. So it always depends.
Okay. All right. Next, I like that. Next on the list is SNR mean, which I guess SNR is that what is that?
Yes, the signal to noise ratio.
That's what I was going to guess, but I thought signal to noise. I was thinking STN, but that's silly. But it's SNR, signal to noise ratio.
Yeah. So what does it mean? So if you record let's speak about speech signals. If you record a speech signal, you have the speech. This is the signal level. So this is the signal we want to hear. And then always, if you record, you have also noise in the background. This can be just the internal noise of your microphone. Then it is low. The level of the noise would be low. It can also be a noise from your fan or from your computer or whatever. Then the background noise level would be higher. So below are also the variables background level and signal level.
Right.
So we measure in each audio segment, we estimate how big is the background level and how big is the signal level. And the signal to noise ratio is just the difference between these two values. So for example, if you have a signal to noise ratio of 30 dB, this just means that your signal is 30 dB louder than your background noise level. Of course, this is just a mean value over the whole file, but these ratios are calculated for every audio frame to process the audio parts.
Right. Yeah, and that would be helpful, I think, because if the signal to noise ratio is very low, so meaning there's a lot of noise and the voice is just a little bit above the noise, you can't really compress and limit that very much, or else you're just going to bring up or else the noise would be the same loudness as the voice, which you can't have that.
Yeah, that's a good point. If you compress the signal, most of the time you will amplify the noise, because compression will lower the parts with higher level. So most of the time this is the signal level, of course, and the background noise level will stay the same. So you will make the signal level more quiet, the background level stays the same, and therefore you will lower the signal to noise ratio, which means in the end there is more noise compared to the signal.
Right. All right, and then there's a section under here, it says music speech segments, which for the file I'm looking at, it starts at 0 and ends and stops when it ends. Is that just tells, like if there is, let's say, two people talking and then they play a song, this is where Auphonic would distinguish between, okay, this is speech and that's music, right?
Yeah, you will see here the music segments, which are bigger than 20 seconds. So, for example, songs or intros or whatever.
Right. Okay, and then under that is noise reduction, and it goes through. Oh yeah, I see. It broke up this file into 7 pieces, 7 different pieces. For the first piece, it says the hum reduction not necessary. The second piece, it says the hum reduction 60 hertz, and it kind of goes back and forth. So yeah, it does break up the file and scan the noise reduction differently for different segments, which is very handy.
Yeah, exactly. Here you can just see the different segments and how much noise reduction is applied, or if some noise reduction is applied at all, or how much hum reduction, and so on.
All right, so Auphonic does not equalize any sound. Is that true?
Yes, that's true.
Okay. Because I was going to ask you about that. Like, is there a way, because here's the problem, and this might be Auphonic 2.0 or 3.0, or this might be Chris Curran program. I don't know. But I have this idea, and this is what I want. Maybe I can place an order with you, Georg, and you can you can make this product that I want. I want a product where I can, kind of like multi-track Auphonic, where I can put in different files for each speaker. And above everything that Auphonic already does, I want it to do equalization as well. Meaning, and not only filter, but like low mids and muddiness. The problem with that is, and this is probably what you're going to tell me, a lot of that, or really all of that, it depends on your taste and the ear. So
exactly
right. So you can't just say, okay, give me an equal spectrum of all frequencies and that'll sound good, because that doesn't work, right? So I'm right?
Yeah, that's exactly the problem why we did not build something like this yet, because we try to automate all things which are technical decisions. Of course, everything is a bit artistic, but most of the decisions we make are technical. And but EQing is somehow much different, because you want to hear your voice. You have a specific vision how your voice should sound, or how another voice should sound, and we don't know your specific vision of it, of course, and everyone wants it different, maybe. But yeah, maybe there are a few things possible. For example, one could make various profiles, EQing profiles in our multi-track version, or provide a reference file how the voice should be EQ'd. For example, if you have a reference file from your voice, and then you tell us, okay, this track should sound like this voice, then this could work somehow. It's called matched filtering.
Got it.
But yeah, it's difficult to communicate and maybe also difficult to use. So that's why we did not build it yet. But it might come in a future version.
Right, yeah, because I've seen some plugins recently that, that'll take the reverb out of signals, that'll clear up a lot of things. There's a lot that can be done, and you're right on the forefront of that. So to finish up here, I want to ask you a question about, okay, we know Auphonic is a great tool. Everyone uses it. Everybody loves it. And yeah, and if you don't use it, just at least check it out. I think you get 2 hours free a month, right, Georg?
Yes, sure. 2 hours per month are free.
Yeah.
And if you need more, you can buy additional credits per hour.
Yeah, and it's not expensive. It's great. So, but here's my question. As a producer or a podcaster or anyone creating audio, so here's the deal. Sometimes I will record, let's say, a phone call through my digital hybrid phone box thing. And, on a phone call, there's a lot of noise. So I will actually run my own noise reduction first, because I can sort of make a noise print, a noise map. And I can take out a lot of noise first and then give the file to Auphonic. And it seems to help. So what can you recommend? Is there anything I can do to my audio before I hand it over to Auphonic to make it sound better?
Well, the most important thing is, of course, good microphone. But yeah, if you have a phone, I mean, you can EQ it if you want a specific sound. You can apply an EQ that it sounds like you want it to sound.
Got it.
But most of the things we try to automate, of course, if you want it somehow different, then you can do some noise reduction before, or whatever you want to do. Because we, of course, do it like we want it to sound, and maybe someone else wants to sound it different. Or you can, of course, also, if you have a different idea of how it should sound, you can, of course, also write to us, and maybe we add some additional parameters. But yes, that's, of course, very subjective, and it really depends on your taste or what you want to achieve. So it's hard to say in general what you should do before or not to do. I would do nothing before, because it's my system, of course. But your mileage might vary.
Right? Yeah. I mean, and that's the only thing I've ever done before uploading something to Auphonic, is on a phone call to just take some of the noise out already. But yeah, I mean, hey, perhaps I have not done an A/B test. Maybe I should do that. Maybe I should run noise reduction myself and then upload it to Auphonic without the noise reduction.
You can try it.
And then just do it. Yeah, but you know what? Come on. Anyway.
I mean, the noise reduction, you can also, if you use our default setting, then the noise reduction will be applied with our automatic adjustments. So this is not that aggressive as some people like it. You can also force to make more noise reduction, then it's more aggressive. So you can also play with this noise reduction amount parameter to get more or less noise reduction.
Right. Actually, yeah, I'm pulling it up now. I just wanted to see this drop down. Yeah, reduction amount. Noise reduction and hum. You check the box for noise and hum reduction, and then there's a drop down. It says reduction amount, and you can choose auto. Auto is the default, and then you can choose 3 dB, 6 dB, all the way to 100 dB. 100 dB.
Yeah, this just means everything.
That's just gone. Bye-bye. Okay.
As much as possible.
Interesting. So 24 dB is high. I think when I run my own noise reduction, I do about 30 dB.
Yeah,
anyway.
Maybe.
Oh, yeah, 30's on your list as well. Cool.
Yeah.
But 100. Yeah, so I might test it, but you know what? I probably won't. I'll probably just, now that I know this is here and how it works exactly, I'll probably just use this one. The other thing I came across with Auphonic, and this just happens. One of my hosts literally records their show in a conference room in New York City right next to a window where you can literally hear traffic. I mean, it's substantially loud traffic. And of course, traffic, there's no, traffic reduction plugin or process. Noise is one thing. Traffic is different. And so when I put the file through Auphonic and it thinks that the truck going by is a voice and it brings it up really loud. So that's, look, Auphonic is not magic. So what I end up doing is I go through the file first and sort of actually just delete the parts where trucks go by and stuff because I just get rid of it. And then I run the file through Auphonic and then it does a great job.
But this first thing is it should not amplify the track because we have classifiers as well, which decide if there is a voice or if there's just some trucks driving by or what else. If it's doing that, please just tell it to us, then we can just add this example to our training data and it won't happen anymore. The other thing is if you just erase the pauses or make it to a 0 signal, then most of the time it will sound very unnatural because you always have, if the speaker starts, the traffic starts as well, and this sounds very strange. So in most of the cases, it is just the best to leave the background signals, or maybe reduces a bit with our noise reduction. This might help as well because they just lower the volume of these segments if you apply very small reduction amount. But a hard noise reduction would not help because it's the background noise changes all the time because some other trucks are driving and something else is happening. Yeah. So this won't work very well. Right.
So you know what, Georg? I will try to look for that file and I'll send it to you. I think I have your email, so I'll just send it to you. And I'm not sure if I have the processed Auphonic file too, but anyway, I'll check out what I have because
can do that.
If it'll help, I'll send it over for sure.
This would be great.
Yeah. So this has been great. Thank you, Georg Holzmann from Auphonic. This has been great. Really, thank you for coming on the show. I know everybody's head is spinning, but I really appreciate you spending the time with us, Georg.
Thanks a lot.
All right, there you have it. So now go take a nap and then listen to this again and take notes. Actually, on the show notes, I'm going to have a lot. But thanks for listening to the Podcast Engineering Show. Again, the website, podcastengineeringschool.com. You can check out our upcoming workshops and everything, which are coming the fall of 2016. Thanks, everybody, for listening. Until next time, you know the drill. Sound great!
Control where change your attitude where you say I just don't get it now. You say your eyes so far away now. You gave up on me where so change your game and give away. You say I wouldn't understand now. You tell me that you found something better. How should I respond to that? Oh yeah, I say now it's a lie. I don't wanna hear it. Why tell you what makes it? It's a lie. I don't wanna hear it. You answer actively. I want you to know you were ever with me through. I've gone over all we've been through. Doesn't seem that long a time now. Things we did still hold that meaning. And does it mean it's still the same? You're pushing me away. You worked your theories now where you get it worked up on you now. You work your way around somehow now. Yes, it hurts me now where that you don't talk to me now. Now that these words have split apart now. You tell me that you found something better. How should I respond to that? Oh yeah,